just going back a little bit, back into the history, my original background when I was studying mechanical engineering, and I actually had a bursary through a well-known arms development company, and as part of my final year project, I had to investigate the airflow on intakes for a missile or rocket, and what we did, we actually used a water tunnel test facility to visualize the flow of air, bringing the water and air, being a hydrofoil and the wing on an aeroplane, together. We could simulate the flow of air in a water tunnel facility, and it was just easier to visualize. But the actual vortexes and the working of the flow is identical in water than what it would be in air. On a hydrofoil is actually, it means a water wing. It's doing exactly the same function as an aeroplane wing. It's creating a low pressure and a high pressure, and that brings the craft to the surface as it's lifting a plane with loads of people on board up into the air. So it's not just a piece of metal or stainless steel sticking out underneath the boat. It's actually perfectly well designed, and the balance between the position, the thickness of the foil, the chord length, the balance between the stern foils and the main foil, the angles of the main foil, stern foils versus the position of the propellers, it's all a very, very fine balance. And if you get any of these parameters wrong, it is as simple as not working at all, and the foils could become an anchor under your boat. It can slow it down. That is the crucial part, and no one, anybody trying to do a hydrofoil by himself without the background knowledge, facilities, test facilities which been used to refine this concept, is not going to get it right. And we've had people that in the past that would mount the foil on a boat, and there would be a 0.5 degree of an angle that is out of balance, and the boat simply doesn't work. And then the balance of exactly where your propellers are going to run, what propeller pitches you're going to use, it's all a very, very fine balance. And the success of our products is really the engineering behind it. And when we sell a boat to a customer, we prefer to be involved with a setup, engine setup, selection of propellers to get the maximum out of the product. Again, with a very efficient craft like a HydroCat, the propeller that you're going to use is going to be slightly different to on a conventional boat. We normally have the position where we would have the pitch of the propeller much higher than on a conventional boat. What it means when the pitch of the propeller is higher, it means that eventually the boat can get much higher speed. But if you're not interested in speed and interested in the economy of the boat, it means that you can run good speed at low RPM. And the lower the revolutions on the engines, the better fuel consumption. Combined with a load carrying capacity of numbers of people on the boat running at low RPM, that gives you the long range, that gives you the performance. So in a nutshell, the balance and the combination of all these elements are crucially important. Unfortunately, this concept has been taken on by various people. People has been asking the question, why is this technology been around for so many years, and why is every other boat on the water not a hydrofoil supported catamaran? And the only answer I have on that is that during the years of development, producing products, producing boats, stepping onto bigger boats, there's been a few copycat products on the market. People that's tried to copy the concept, they don't get it right. They put a product on the water and it doesn't perform well, and people will say the concept doesn't work. So it's crucially important to understand exactly where your product comes from, where the technology comes from, who's behind the technology, and make sure that it is from the real stable, the original concept and the original HydroCat product.